Thank you very much for inviting me to the Ammonia Energy Association Australian Conference. In this presentation, I'm providing some estimate of the investment needed when ammonia is used to decarbonize this industry. My name is Carlo Raucci and I'm a principal consultant at UMass, University Maritime Advisory Services. As I was mentioning, it's important to decarbonize international shipping. It accounts for about 3% of the total CO2 emissions. For this reason, the International Maritime Organization has committed to reduce GHG emissions by at least 50% by 2050. This is shown in this plot, where you can see a business as usual trajectory and two decarbonization trajectories. One with the minimum IMO target, and another one with the full decarbonization by 2050, which is in line with 1.5 degree Paris Agreement. As you can see from this plot, we need to close this gap. This is the challenging that we are facing. And we also know that there is only a share of this gap that can be closed by using energy efficiency measures. In order to close the gap, we need to switch to zero carbon fuels. So we have used the shipping model of UMass in order to simulate a number of scenarios, a number of decarbonization scenarios. And as you can see from this slide, you have two scenarios here. One with a full decarbonization by 2050, and another one is a decarbonization by 2070, which is essentially in line with the IMO objective. As you can see from this fuel mix, from 2030, we see a significant uptake of ammonia. This scenario suggests that ammonia is likely to represent the least cost pathway for international shipping. This can be highlighted also in this other plot that is from another studies. In this plot, we are showing what we call the total cost of ownership. Total cost of ownership is composed of voyage cost, engine cost, storage cost, but also the costs associated with the cargo capacity, loss of cargo capacity, due to larger tanks that may be required for some of these fuel on board ships. What we can highlight from this plot is 2 points. One, that voyage costs represent a significant share of the total cost of ownership. And second, that ammonia has the lowest TCO amongst the other fuel competitors. This is why in the fuel mix, we see that ammonia could be the least cost option pathways. So having established so, we start to estimate the investment needed with such type of uptake of ammonia. We can divide the investment in two main, parts. The investment needed for the supply infrastructure and the investment needed for the technology on board, so engine and storage technology on board. This varies across scenarios and production pathways. However, we see that the cumulative total capital investment by 2050 is estimated to range between 1 and 1.9 trillion. One common element across these scenarios is that the investment in fuel supply infrastructure represents the majority of the investment needed. The majority about 85% and 90%. This has to be compared with the ammonia demand, the projected ammonia demand up to 2050. And as you can see from this plot, in these scenarios, we see a large increase that can represent a potential $5 trillion market by 2050. In other words, this would be a plus 400% capacity increase relative to the 2008 global ammonia production capacity. My final slide here is to suggest some reading. Obviously, you can find the full set of slides for these studies at the link here. I have also included the link of other studies, the technical economic assessment of zero carbon fuels, but also some other studies like that we have recently done, the fourth IMO GHG studies and Poseidon principle, where you can see how we are helping banks to finance zero emission ships. I hope you have enjoyed this short presentation, and feel free to contact us if you have any comment or feedback. Thank you very much.